Hello everyone, this is Amraja Shivkar and today we are going to learn Introduction to Pentium. So the question is, what is Pentium? Let's go back in history and search the answer. By history I mean we have to see the evolution of microprocessors. So we have to first see the first generation microprocessor. The example for which is Intel 4004. It was the first microprocessor introduced by Intel. Its word size was 4-bit. Word size is nothing but data bus size. So data bus of Intel 4004 was 4-bit. Its address bus size was 10-bit. Address bus size can tell us about addressable memory by applying the formula 2 raised to address bus size. So here we get addressable memory equals to 2 raised to 10, which is nothing but 1 kilobyte. So the total memory size which is addressable by Intel 4004 is 1 kilobyte. Then came second generation microprocessor, the example for which is Intel 8085. Data bus of 8085 is 8-bit, making its word size 8-bit, while the address bus of 8085 is 16-bit. Hence, again we apply the same formula. 2 raised to 16 is its memory size. 2 raised to 16 can be split into two parts. 2 raised to 10 into 2 raised to 6. 2 raised to 10 is 1 kilobyte as we see in this example. So 2 raised to 10 is nothing but 1 kilobyte. What is 2 raised to 6? It is 64. So 1 kilobyte into 64 makes the memory size 64 kilobyte. Then came third generation microprocessors, the example for which is Intel 8086. It has word size, that is data bus size of 16-bit and address bus size here is 20-bit. So again the memory size becomes 2 raised to 20, which is nothing but 1 megabyte. After which came fourth generation microprocessor. The very first fourth generation microprocessor was Intel 80286. The data bus size for which was 16-bit, which is nothing but word size. The address bus size for Intel 80286 is 24-bit and memory size for Intel 80286 is nothing but 2 raised to 24. Let's calculate again. 2 raised to 20 is 1 megabyte and 2 raised to 4 is 16. So making the total memory size equals to 16 megabyte. We have one more example for fourth generation microprocessors, which is Intel 80386. Word size here increases to 32-bit. So we have wider data path. Address bus size is 32-bit again, making the total addressable memory size equals to 2 raised to 32. 2 raised to 30 is equal to 1 gigabyte, while 2 raised to 2 is nothing but 4. So the memory size here becomes 1 gigabyte into 4, which is nothing but 4 gigabyte. And now we have 5th generation in this. Here comes our Pentium. So the example for 5th generation microprocessor is Intel Pentium. Word size for which is 64-bit, making its data bus size 64-bit. Remember, data bus and word size are the same. Address bus size in this is 32-bit. So again, the memory size is 4 gigabyte. As you can see, 5th generation microprocessor, that is Intel Pentium, has the wider data path because its data bus is 64-bit wide as compared to the other processors which had data bus size less than that. But do you think 5th generation was the last? No. Even after Intel Pentium, we had few more processors. There was an entire Pentium series which consisted of Pentium Pro, after which came into picture Pentium 2. It was followed by Intel Pentium 3. Then came Intel Pentium 4. Again, this was not the end. After Pentium series came Intel's Itanium series. You might have heard about it. So here we had i3. I stands for Itanium here. Then came i5, after which came i7, then i9, and still going on. You guys might have heard about i11 as well. So, technology is progressing. But, where were we? Let's go back. We were talking about Pentium. So let's study Pentium in detail. In this lecture, we have to see the features of Pentium. As we have seen earlier, it has 64-bit data bus, making its word size 64-bit and hence providing wider data path. Word size is 8 byte. What does that mean? We all know that 8 bits is equal to 1 byte. So 64-bit is nothing but 8 bytes. So word size here becomes 8 bytes. We have seen earlier that it has 32-bit address bus, hence making its total addressable memory equals to 2 raised to 32. As we have seen earlier, 2 raised to 30 stands for 1 gigabyte and 2 raised to 2 stands for 4, making the total addressable memory equals to 4 gigabyte. It has double on-chip cache. Cache is a small, fast memory, and to make it faster, in Pentium we have two different cache. One 8 kilobyte cache for instructions or code and a separate 8 kilobyte cache for data, making the Pentium to work faster. Pentium uses superscalar structure. Now what does that mean? It simply means the instructions which are executed at higher speed. Why? Because multiple instructions are executed in one cycle. So superscalar structure will allow multiple instructions to be executed in one cycle, which is going to increase the speed of your microprocessor. It also allows pipelining. Now what is that? Pipelining means overlapping of instructions. So multiple instructions will be overlapped and there will be fetched, decoded and executed simultaneously, again increasing the speed of the processor. It has branch prediction logic. What is branch prediction logic? It simply means that because of this, the programs which have branching instruction or the algorithms which contain branch will be executed more efficiently. In next lecture, we will study registers of Pentium processor. Till then, thank you.